So, we will do that both we have prepared ice cream cups and of course, cones are also like that from the like the cups, the cones are also being filled like that physically. And in this dairy and food process and products technology, today's 56th lecture, we will discuss about overrun and how the ice cream mix are being prepared, right. So, there is a proof sheet, that is they call it to be proof sheet, because you are an engineer, you know, but the workers who are working, they do not have that much of thing. What they need, they want a proof sheet from you, you being the boss, they will ask from you that give me that proof sheet, and that will give him that how much what has to be added for the mix to be prepared, right. So, this is what, but before that, as we said in the ice cream preparation, that incorporation of air, right. So, if incorporation of air, and I gave this example also, that that drink, that drink in the sense soft drinks which are being sold in the market, that is basically water and some other constituents. Here it is basically air and other constituents. So, that is why the control body, they must have put some mechanism, so that the minimum things are there, such that the consumer is not getting befooled, right. So, here also assume that if you have out of 50 ml or 100 ml, say out of 100 ml ice cream, if you have only around 30 ml of material and rest of the thing is only air, in such a way that only air 70% air is there, 30% your material, then of course, you will be fooled, right. Simultaneously, if the manufacturer has to put say 70% your material and 30% only air, then that will not be ice cream. So, and unnecessarily that will shorten the profit of the manufacturer. Nobody will come forward to make the ice cream, and also the quality and the taste will be different. So, that is why there is some guideline, some regulations by which how much material and how much air you can put in one ice cream, that has a definition, and this is done by the term called overrun, right. This overrun is associated only with the incorporation of air, right. So, overrun means you are running one thing and how much extra you are putting in it in terms of air. How much air you are putting into it, that is dictated by the term overrun, right. Now, you obviously this we know that air density is very low, right. So, density is very low means air volume will be very high, but the mass will be very low, right, for a since its density is very low, right. Whereas, ice cream mix, which is a mix of fat, protein, carbohydrate, vitamins, minerals, whatever there all put together. So, their solid content is very high, right, and the density is also very high. Since the density is very high, there for a given mass volume also will be very low, right. So, to balance it, this definition of overrun is made either with respect to volume or with respect to mass, right. So, if because it is not may not be possible all the time, you will define only by volume. Sometimes you may need to define in terms of mass, which you can measure. Volume of course, also you can measure, right. So, both the possibilities are kept. So, overrun is defined accordingly, right. So, let us look into how overrun is defined. Overrun is defined like this, that by volume percent overrun, this is called percent overrun, is volume of ice cream mix, volume of ice cream. Ice cream means your mix plus air, that is the ice cream, right. So, ice cream. So, mix of what? Mix of ice cream and plus air, this put together makes the ice cream, right. So, your volume of ice cream where air has been incorporated is less, rather volume is more, right, volume is more, and volume of mix whose density is high, that will be less. So, volume of ice cream minus less volume of mix over volume of the mix times 100 is the percent overrun, right, by volume. So, percent overrun by volume by definition is volume of ice cream mix minus volume of ice cream, all the time I am mistaken, volume of ice cream minus volume of ice cream mix over volume of mix times 100 is the percent overrun, right. So, we have example also in front of us. Suppose we have volume of ice cream mix 9.5, say 9.5 ml, right, 9.5 ml of ice cream mix you ice cream you have, right, or here we have given that is already there. So, we take 50 ml of ice cream we have taken, right, and the ice cream mix we have a volume say 25 ml, right. So, 50 minus 25 by 25 into 100. So, that becomes, this is 25 by 25, this is 1 into 100. So, your overrun is 100%, right. Here we have taken 9.5 minus 5 over 5, this is 4 by 5 into 100, that is 90%, 9.5, 9.5 minus 5, that is 4.5 over 5 is 0.9 into 100 is 90%, right. Here we have shown it to be 100% by volume, right, because ice cream has more volume than the ice cream mix. The reason being, ice cream contains the mix, that is the solid and liquid and air. So, volume is more. Ice cream mix does not have any air. So, ice cream minus ice cream mix, that is whose volume is less, over the ice cream mix volume times 100 gives us the overrun in terms of volume, right. So, all the time this may not be possible. Another example, if we take that, if we have 60 ml, no 60 is not commonly, say 100 ml, we have 100 ml of ice cream and out of which we have 60 ml of mix, right, out of which 60 ml of mix over 60 ml of mix times 100, this becomes 40 by 60 into 100. So, that means it is 4 by 6 into 100, that is 2 by 3 into 100. So, that is equals to 2 by 3 means 0.66. So, 66.66% you have overrun, right. So, that means your overrun is much less, right. You can have, so 100 ml ice cream in which 60 ml mix you have given, and you have an overrun of 66.66%. You will think that I am getting more quantity. So, but again the ice cream itself, for that the palatability, the taste, for that there has to be some quantity of air minimum, otherwise you will not enjoy. There is a difference between ice cream and kulfi, right. Kulfi is also made from the similar ice cream mix, but kulfi does not have overrun. It is almost negligible, around 4, 5, 10% overrun, right. As minimum it is getting incorporated 4, 5, 10%. So, there it is, majority is the solid. Obviously, the taste of kulfi and the taste of ice cream are, or palatability, are not identical or same, right. So, it is not that if I want to give my customers more quantity, that may not be possible, because that will not be the ice cream, that will be a solid mass which may not be so palatable. So, 66.6% which we have come for this 100 ml of ice cream with 60 ml of mix, ice cream mix, right. And this is not your ice cream mix, means this is not only solid, but also the liquid. The mix is the entire thing, solid, liquid all put together before it goes to the freezer, that is called the ice cream mix, right. So, this ice cream mix, it is not the I can give more or you can give more or you can give less. This is one example of getting the overrun very low. Another one, I have not calculated, I am doing it on the floor itself, that another one, again if we take 100 ml cup, and out of which if 30 ml is the mix, and if 30 ml is the mix volume, then into 100, that becomes 70 by 30 into 100. So, that is equal to 2.33, right. So, that means it is into 100, it is almost 233% your overrun, right. So, in 100 ml ice cream, you have given only 30 ml mix, and rest of the thing is your air, right. So, that means the consumer is getting only air, or majority is air. So, he will be deprived. So, he will buy for 10 rupees, 20 rupees, whatever be the value, 50 rupees, I do not know, that depends on the variety, etc., etc. Whatever be the price, out of which he is getting a very small quantity of the material as a mix and large quantity of air. So, that is he is getting deprived. So, you cannot, and here of course, by that your profit is very high. because you have given air which has no value, virtually no value, right. Only the air which goes into the ice cream freezer, it is supposed to be clean and aesthetically, not only aesthetically, microbiologically it should be clean, so that it does not incorporate any infection to the system, because after when you are mixing, it is all getting cold, you are not getting any chance of heating or cooling. So, air has to be under very clean condition without any having any source of infection or any contamination with the microbial load, that must be there, right. So, this we have to keep in mind, and not only this, we have to keep in mind that the air which you are giving there, this air will go and mix with the ice cream mix and then make the ice cream, and when you are consuming, that time if that air is already contaminated, so that will be already inside. So, you have consumed and there is a chance of you getting infected if the air is containing some airborne organisms, right. So, that is why it has, though it is we are saying that air is free, but your cost involvement is only there that when you are passing this air, you must disinfect this air before it is going into your system, right. This is a must, this is a compulsory, otherwise it will be infected. However, it is making 233% in under this situation. So, that is not desirable. You are fooling your customer, consumer is getting deprived, not possible, right. So, there must be some process, there must be some mechanism by which neither consumer will be deprived nor the manufacturer also will run with a loss, because he is manufacturing for profit to gain his bread and butter. So, that will come from the profit and that will be given to the also the people who are working, the workers, etc. So, a minimum profit has to be there, because ice cream mix, that will also cost. It is not that entirely like air everything is free. So, air is also become costly because you have to disinfect it. This disinfection will also cost you a little, may not be very high, but a little disinfection cost has to be involved. So, there must be some provision, there must be some guideline by which neither you make it to 33% nor you make it 66%, right. So, if it is to 33%, then you are gaining a lot, that is the manufacturer is getting a lot, but if it is 66%, then manufacturer is giving much more and you as a consumer is gaining very much. So, that is also a loss to the manufacturer. So, neither it should be a loss to the manufacturer nor it should be depriving the consumer. Such thing has to be given, and the controlling authority has kept this thing in mind, and that is why made that any ice cream cannot have less than 90% overrun or more than 105% overrun. So, overrun should vary between 90 to 105. If it is less than 90, then that will be a loss to the manufacturer. If it is more than 105, that will be again depriving the consumer. So, neither the consumer is deprived nor the manufacturer is getting a loss. For that, there is this binding that the 105 to 90, within this the overrun has to be there, right. 90 to 105, that has to be there. So, like that here we got it 90. So, this is a typical example that it is 90, 9.5 minus 5 by 5 over 100 into 100 is 90%, right. So, it is likewise it can be up to 105%, right. So, this is by volume. Similarly, if we look into by weight, then we get by weight, it is like this: percent overrun is weight of the mix. In earlier we have said mix has high density. So, low volume, more weight. So, weight of the mix of 1 gallon minus weight of the ice cream of 1 gallon. This is gallon is a volume. So, you can make it that weight of ice cream mix of say 100 ml, right, minus weight of 100 ml ice cream, right, or divided by weight of 100 ml ice cream, because ice cream will have less weight than ice cream mix, right. So, 1 gallon or 100 ml, that is a definite volume. For a definite volume of the both mix and the ice cream, if your weight difference is known, divided by the smallest weight, that is the ice cream weight in this case, times 100, that will give us the percent overrun in terms of weight. Generally, commercially, this percent overrun in terms of volume is very much popular, because that you are making that ice cream not by weight, you are selling ice cream not by weight. You are going to the parlor or any ice cream shop where your ice cream is available, you are going and asking that give me a 50 ml cup or 100 ml cup or maybe 1 liter or maybe 4 liters gallon, that you are telling all in terms of volume, right, all you are telling in terms of volume, but not in terms of the weight. That is why the percent overrun by weight is less popular than, not only less, normally commercially in the shop floor it is not there, it is all by the percent overrun by the volume. However, to have the idea, we have given this, that percent overrun by weight is say 8.85 is the weight of the 1 gallon of mix, right, or one known volume of mix minus weight of the same volume of ice cream, that is say 5.06 over the weight of the same volume of ice cream, that is 5.06 times 100, this gives 74.9% overrun, right, and generally 1 gallon is 3.7854 liter. But in our country, in all ice cream industry, they make 1 gallon. It is still, it is said gallon container, gallon ice cream, that is still being said, but the quantity put is 4 liter, not 3.784. This is the 4 liter. Accordingly, price is also whatever would have been with 3.784, that is converted into 4 liter correspondingly, and the price is held for that 4 liter, right. So, when you call it to be gallon pack, then it is a 4 liter pack. If it is a party pack, then it is a 1 liter pack. So, generally they have these volumes, your lollies, that is different, then 50 ml, then 100 ml, then 1000 ml, then 4000 ml. These are the generally 4 types of volumes they are used, right. I repeat, 50 ml, then 100 ml, then 50 ml, then 100 ml, 50 ml, then 100 ml, and then 1000 ml 1 liter, then 1000 ml or 4000 ml. These 4 volumes are normally with the ice cream industry, right. So, you will not get in between 2 liters, you will not get 5 liters like that. So, these 4 are the volume quantities you will get in the market: 50 ml, 100 ml. 50 ml was not there, maybe couple of decades back it was introduced in the ice cream industry, because when the price was going up, then they thought that 100 ml may be too costly to buy. So, let us make it half of that. So, 50 ml came in, right, and the price became almost close to half, and that is why people could buy. Those who are not so rich, they can buy. So, that is why, to make it more popular, to distribute it amongst many people, so 50 ml was also introduced, right. And ice cream lollies, they are having the fixed more or less volume, more or less. Yes, there will be this side, that side, some more, some less, depending on the how many numbers of layers are there, right. So, you will see that there are on chocobars and many others, they are one type, multi layers another type, that is again they are depending on the manufacturer, whether it is made from Amul, made from Vadilal, made from Quality, or made from any other. So, they will have a slight variation, but not much. But these cups and party packs or gallon volumes, they are fixed everywhere, right, and accordingly this is made. Okay. Then we have spent a lot in it. Let us go into quickly an example, right. Say if 20 liter of fruit weighing 5 kg per liter is added to 100 liter of mix weighing 4.5 kg per liter and 200 liter of ice cream is produced, what is the overrun in the mix? So, we get the overrun to be around, here we have seen that from this calculation 66.6%, right. Then actual overrun is 200 minus 100 plus 2 into 100 by 100 is 80%, because this was by weight, right. Now, as I said earlier that when I was saying about the vertical and both horizontal, when it is going as a from 4 degree to minus 5 degree. So, you see I have given it in Fahrenheit, because these are the whole numbers. So, when 25 you just convert into centigrade, 25 Fahrenheit 33% of the water is frozen, 24 Fahrenheit 41% of water is frozen, 23 Fahrenheit 47%, 22 52%, 21 56%, 20 59%, 19 62%, 18 64%, 17 67%, minus 15, 90%. I hope you know that there is one temperature where both Fahrenheit and centigrade are same, and I hope you know that that is minus 40. So, minus 40 Fahrenheit and 40 centigrade are same. However, we are not going to that. So, it shows that if you have a plot of say temperature versus percent water frozen, percent water frozen is dependent on temperature, right. So, this is percent water frozen. So, if we plot that, so as if this is 25, 24, so minus 15. So, if this is 0 and minus 15 is here, right. So, if our plot is minus 20 to down below there, then obviously you will have one asymptotic thing like this, right. So, one asymptotic sorry. So, this is 0 or something and minus is this way, right. No, then that will be the so we have Fahrenheit here and we have percent here and we have minus 20 here and we have plus say 0 or 20 or 30 Fahrenheit here, right. If that be, so 30 Fahrenheit is 33%, 30 Fahrenheit is 33% and 90 minus 15. So, here is 90%. So, that means your thing is going like this asymptotic, right. So, percent water frozen become, and this is telling about the bound water, right. This is telling about the bound water. Okay. I hope we have crossed the time today. So, let us stop today here. Thank you.